Okay, number 1 through 3 have the instructions express the interval as an inequality and graph the interval on a number line. So I think it's easier to graph it first, because when we see this, we're saying that x has to be between -3 and 7, and so that means that, remember, we put a parentheses when we see parentheses. Parentheses means not equal to. We put a bracket where we have a bracket, which is at 7, which means it is equal to at 7, and then we're saying x has to be between those, so we're shading between. That's the graphical part of that. Now the inequality, we're saying x is between those, so there's two ways you can write that. You can write that as -3 is less than x is less than or equal to 7, and when we do that, we just, anytime there's two numbers here, we put them in order from least to greatest is what's happening. So we're saying -3 has to be less than x, because -3 is the smallest that we can be, and then x has to be less than or equal to 7. Or if that is giving you issues, the other way to say it is you could say, well, x has to be greater than -3 and x has to be less than or equal to 7. Okay, so writing it one of those two ways would be the answer. Number 2, we need to remember what negative infinity means, because negative infinity is way far over here on the left of our number line. Like if we could keep drawing that line to the left forever and ever and ever, at the end of that line would be negative infinity. So our x has to be between negative infinity and 8. So I draw a bracket at 8, and then I shade to the left because I'm shading towards negative infinity. And what I do is I put an arrow at the end to say it keeps going forever and ever and ever. It doesn't ever stop because we can't actually get to negative infinity. The reason I like to graph first is now I think this is easier to write the inequality for, because remember that whenever we just have one number like this with 8, we write x, and we have to figure out, is this going to be less than or greater than 8? And since we shaded to the left, that's going to be a less than symbol, because remember the symbol points the direction that we're shading, so it's pointing to the left. Since it's a bracket, it is equal to, and then we put an 8. So this graphical representation is saying that x has to be less than or equal to 8. Number 3. We have -4, infinity. So where is positive infinity? It's on the right side of our graph. We could keep drawing the right side of our line forever and ever and ever, we'd get to positive infinity. So we put a parentheses at -4 because this is a parentheses. So we put it at -4, and then we are shading towards positive infinity. So we shade to the right towards positive infinity. Then if we write the inequality for this, now we're saying that x has to be bigger than -4. Since it's a parentheses, we don't put the equal to sign on it. It's just x is greater than -4. That's the first set of problems. And then we want to look at, on 4 and 5, we're just solving some fairly simple inequalities. We're solving some fairly simple inequalities. So here I go on number 4. I need to get x by itself, so I subtract 5 from both sides to start off. 2x becomes less than 8, so I divide by 2 on both sides. Remember, if we divide by a negative or if we multiply by a negative, we flip the sign, but we didn't do either of those, so we wouldn't flip it. X is less than 4. That's us solving this inequality. It wants us to write the answer in interval notation and graph the solution set. So x is less than 4, I draw a parentheses at 4, and then I shade to the left. Okay, because remember that our inequality, if you look at this and pretend it's an arrowhead, basically, it's pointing to the left, so that's the direction we shade. So that's the graph, and then to write this in interval notation, remember that negative infinity is over here, and we're saying that x has to be between negative infinity and 4. 5, same directions. We need to pick a different color. Here's one. Okay, we need to get our x's on one side, our numbers on the other. So I'm going to move my x over to the left side, and in general with inequalities, I feel like it makes it easier if you always move the x to the left, even if that would make it a negative on the left side. Okay, 6x minus 5x is x. Write down what the rest of this is. Now we need to get our numbers on the right side, so add 4. So x is greater than or equal to 1. So that means I put a bracket at 1, and then I'm going to shade to the right. So I put a bracket at 1 and shade to the right. And then for interval notation, now we're saying that x has to be between 1 and positive infinity. So 1 comma positive infinity, that's our interval notation. 6 and 7 ask us to find the intersection of the sets, and that's what the directions will look like on the test. And so if you can remember that the in looking symbol goes with intersection, that's great, but you don't really even have to remember that. You just have to remember the word intersection. The word intersection, if you think about in real life, when we have streets that are intersecting, okay, what does that mean? It means that our streets are crossing, right? So if you can remember the word cross, and you can look at this and say, where do these sets cross? Where do these numbers cross? What we're saying is, what do they have in common? Okay, so the numbers they have in common is b, 3, 6. And that's the best way of remembering it that I've come up with, is that we're trying to see where these sets cross, and so they cross where they have things in common. On number 7, then, this is kind of a trick question almost, because if you look at this, they don't have anything in common. So which of these answer choices would we pick if they don't have anything in common? We'd pick D. Now, I think we've used this symbol enough, hopefully, for you to know what it means, but that symbol means no solution. Sometimes we say it means no solution, or we're talking about that it's the empty set. And so what do they have in common? Nothing. So there would be nothing in the set of the stuff they have in common. So that's what we would pick there, is D. On numbers 8 through, I think it's more than 10, our instructions are to solve the compound inequality, graph the solution set, express the solution set in interval notation. So all we have to do here on 8 is graph this, basically. There's nothing to solve. We have x by itself in both cases. So x is less than or equal to 1. At 1, we would shade to the left. X is greater than or equal to -3, so at -3 we'd shade to the right. And so what's happening is both of those have brackets, and we would shade in the middle of them because they're pointing towards each other. At 1, we're pointing to the left. At -3, we're pointing to the right. So we're shading what they have in common, which is here in the middle. And so another thing is that anytime we have an and, that's what should happen, that we shade between whenever it's and. The interval notation for this is we're saying that x has to be between -3 and 1. So that's how we write it. X is between -3 and 1. On 9, we do have to solve a little bit because we have to divide both sides by 6 on this first one, which gives us x is less than 5. The second one, we need to subtract 6 from both sides, so that gives me x is greater than -1. So at -1, we're going to be bigger than -1, and then at 5, we're going to be less than 5, so we're shading between. Again, because that's what the inequalities are telling us, and because it's an and because it's an and, haha. And then -1, 5 is our interval notation, because we're saying x has to be between -1 and 5. This next one now, this may be a little bit trickier. When we discussed this, we did it 2 different ways. We talked about how you can split this up into 2 different inequalities and then solve those inequalities. Okay, and that is certainly a good way of doing it. The other way of doing it, though, is to say, I'm going to solve for the middle of this, and whatever I do to solve for the middle, I'm going to do to all three parts of this. Like there's a left part, there's a middle part, and there's a right part. Okay, let's think of it that way. So I'm solving the middle part, but I have to do it to all three parts. What I mean is if I want to get x by itself in the middle there, I would subtract 4 from both sides. So, but what I'm saying is we don't just have both sides. We have both sides on both sides. Okay, we have to subtract it from all three parts of this. It cancels out the thing in the middle, and it gives us 10 is less than or equal to 5x is less than or equal to 35. Okay, and then we keep going. How do I get the x in the middle by itself? I divide by 5, which means I divide everything by 5. So that gives me 2 is less than or equal to x, which is less than or equal to 7. So we're going to shade between 2 and 7. That's what this notation means, is to shade between 2 and 7. They're both equal to, so we get brackets between 2 and 7. Okay, and then our interval notation here is 2, 7 with brackets, because we're saying we have to be between 2 and 7. All right, the opposite kind of intersection is union. And so the way I like to remember union is when we think of union, think of marriage. Think of you getting married to someone, and think about how when you get married, you take all of your stuff and you take all of the other person's stuff and you put it all together. So that's what's happening here. When we union two sets, we take them and we put everything together. So if this set has -5, -1, 3, and 6, this one has 3, 6, 9, then we need this set that has all of those numbers, which is -5, -1, 3, 6, and 9, which is C. So if you can think of marriage and union together, then you can remember what that means to do. Number 12 and number 13 should have really had the same instructions, but I didn't fix 13 apparently. Something happened there. So solve the compound inequality and graph the solution set on a number line. Express the solution set in interval notation. So I need to do x is less than or equal to 2. So that's a bracket at 2, and then I'm pointing to the left. Okay, and then I have x is greater than or equal to 5, so that's a bracket at 5. Oops, I missed the mark a little there. X is greater than 5, so we shade to the right at 5. And then for interval notation, remember that we've got negative infinity on this side, we've got positive infinity on this side. For this, we have to split this up into two things because our graph is split up into two things. So this part of our graph is negative infinity, comma 2 with a bracket. This part of our graph is 5, comma positive infinity. So that's our interval notation. Number 13, we need to solve these. So on this first one on 13, I subtract 1 from both sides, and I get -5x is less than or equal to 10. Divide by -5 on both sides. And since we divided by a negative number, that means that I have to flip the inequality and make it greater than or equal to -2. Let's do the second one now. I would subtract 3 from both sides and get 7x is less than or equal to 22. No, it's -25 minus 3, which is -28. Okay, -25 plus -3 is -28. Divide by 7 on both sides, and you get x is less than or equal to -4. So we're less than or equal to -4, which means we shade to the left of -4. We're greater than or equal to -2, so we shade to the left of -2. And then we put our interval notation. The part on the left here is from negative infinity to -4. The part on the right is from -2 to positive infinity. Number 14 through 16. is talking about absolute value equations. So remember that what we do is we make sure our absolute value is by itself, and if it's by itself on its side of the equation, then we can split this up into two different equations. The first one is just whatever it is with the absolute value bars drop, so x equals 3. The second one, you make the right side negative. So for 14, our answers would be 3 and negative 3. For 15, though, we'll have to do just a little bit of work. We have to, since this is by itself already, we have to split it up. So we say x plus 3 equals 7, but also we have x plus 3 equals negative 7. So we subtract 3 from both sides, and we get x equals 4. Subtract 3 from both sides, and we get x equals negative 10. So that's number 15. Number 16, we have something on the same side as our absolute value. We have a negative 8. So we need to add 8 to both sides to move it, because we want the absolute value by itself before we split up. You cannot split up the absolute values until you've gotten it by itself. So I get 4x minus 1 in absolute values is equal to negative 3. Then when we go to split it up, hang on a sec, absolute value equaling a negative number, that doesn't work, because whatever x is inside of here, whatever number we get, the absolute value bars make positive. So a positive number can never equal a negative number, which means there's no solution. As soon as you see that you have a negative over there on the right side of your equation, if your absolute value is by itself like that, that's no solution. You can stop and just write no solution and not keep going. All right, solve and graph the solution set on a number line. Now we have absolute values, but we have inequalities. So it only changes what we're doing a little bit. If we have the absolute value of x is less than 3, we still split it up into two things, where the first one stays the way it is. The second one, we not only make negative like with the equations, we also have to switch the inequality sign. So we end up with x is less than 3 and x is greater than negative 3. So it's less than 3, which means we'll shade to the left of 3, but it's greater than negative 3, so we'll shade to the right of negative 3, which means they meet in the middle. This doesn't say to do interval notation, but let's do interval notation. I'll make sure that it is very clear on the test whether or not you need to do it. The interval notation here is that x is between negative 3 and 3, so there it is. Excuse me. Then, 18, we have to actually do a little bit more work this time. We split it up. We say x minus 4 is less than positive 7, and we also have x minus 4 is greater than negative 7. On that second equation, you have to flip the inequality and make it negative. So we solve here, add 4 to both sides. So x is less than 11. Add 4 to both sides. So x is greater than negative 3. So we're less than 11. So we put a parentheses at 11. And we draw to the left of 11. That's where we're shading. We're greater than negative 3. So we put a parentheses at negative 3. And we shade to the right. Our interval notation for that, we're between negative 3 and 11. So that's our interval notation. Number 19. Now we have x is greater than 8. And also x is less than negative 8. So at negative 8, we're less than, which means we'll shade to the left of negative 8. And it's greater than positive 8, so positive 8 greater than. The interval notation for this will be negative infinity to negative 8 and 8 to infinity. 20 is kind of a monster of a problem, maybe a little bit. Because we have to first get the 3 over to the other side. We want the absolute value to be by itself. So we subtract 3 from both sides, and we get the absolute value of 1 minus x over 2 is greater than or equal to 2. Okay, and so a lot of mistakes happen because we try to do more than one step at the same time, but you have to just do that first, and now we're ready to split this up into our two inequalities, where one of them is 1 minus x over 2 is greater than or equal to 2. The other one is 1 minus x over 2 is less than or equal to negative 2. So we solve by subtracting 1 from both sides. You get negative x over 2 is greater than or equal to 1. To get this negative and the 2 to go away on the left side, we have to multiply by a negative 2 on both sides, because that will cancel out these and leave us with x multiplied by a negative, though, which doesn't happen very often, but it did in this case, so we have to flip the inequality. X is less than or equal to negative 2. Then we go through the same process on the right here. So we subtract 1. We multiply by negative 2. So that it cancels out what we need to on the left side. So x, oh, I forgot, we have to flip the inequality. X is greater than or equal to a positive 6. So we're less than or equal to negative 2. And we are greater than or equal to 6. Graph the inequalities. So there's two things we have to remember for this. If there is a line underneath, which means that we have an equal to situation, then that means we need a solid line. But if it's not equal to, so there's not a line underneath the inequality, then it's a dashed line. Okay? If we have two variables and we have a greater than or equal to situation, we shade above. If it's less than, we shade below. So let's look at one of these, like 21. Y is greater than or equal to x minus 3. So our y-intercept is negative 3, so we go on the y-axis to negative 3. We put a dot. Our slope here is the number in front of x, which would be a 1. So remember, slope is rise over run, so we need it to be a fraction, 1 over 1. And since they're both positive, we go up 1 and right 1. Okay, this is equal to, so it'll be a solid line. So something like this. Okay, that's the first part, is that we drew the line, but we're saying that y is greater than or equal to that line. So that means I'm going to shade above this line. Well, you might ask yourself, this is not for pre-calc, but my college algebra kids will appreciate it. We shade above this line. So one way to figure out which way is above is you take your pencil and put it on the line anywhere you want to. If we want to shade above, draw an arrow going up. The side that your arrow is on is the side that you need to shade. So this is the side that I would shade. Right here. Lots of beautiful shading right there. Okay, so don't forget that you have to shade. It's really important. 22, in order to graph that line, I need to solve it for y. So subtract your x over to the right side. We get y is less than negative x minus 2. When we draw this, remember it's not equal to, so it's going to be a dashed line. So we draw negative 2, and then we're going down 1 and right 1. Because this is a negative 1. So our slope is negative 1 over positive 1. So we make it like a dashed line. And then we want to shade less than that line. So where is less than? It's below. So pick a place anywhere on your line, draw an arrow going down. That's the side you need to shade. Because that's where we are less than. 23. X is greater than -3. So this is a completely different 23 and 24. We graph these almost completely different than the way we do if it's got y equals mx plus b. Because there's only one variable here, which means no matter what y is, no matter what our y values are, x is all, if we graph x equals -3, x is always -3. So we go to -3 on the x-axis and we draw a vertical line. Now, it's not really x is equal to -3, it's actually x is greater than -3. So that's a dashed line. And it's bigger than -3, so that's this direction that we would shade. And the way you remember that is think back to, for one thing, think back to the things we've done on a number line. Which direction did we shade if we had x is greater than -3? We shaded to the right, right? So that's the same thing here. Even though we have two variables, it's still shading to the right. 24, we need to shade less than or equal to 3. So we go to 3 on the y-axis and we draw a horizontal line. And since it's equal to, it's a solid line. Less than or equal to, just like before, we can say, okay, well, we're going to graph below, and hopefully it's obvious on this one which direction is below, but hey, maybe it's not, so you can make your little arrow there and figure out which way is below. Okay. Now let's graph some systems of inequalities. So a system of inequalities, what we're looking for is where, if we draw these two lines and then we shade them, where does their shading overlap? That's the answer for a system of inequalities. So we draw the two lines. So I draw my first line, which is at a y-intercept of 3, and it has a slope of 4/1. So I go up 4 and right 1. And we just draw, oops, I went over too far on that. We just draw our line, and it's equal to, so that's a solid line. So, that's a terrible line. Okay, so we draw a line. Hey. And then it's less than that line, so I shade less than, which is going to, if we take a point on here and we draw an arrow going down, that's going to be this side, but shade it lightly because we're not done yet. Okay, but we know we're going to shade this part of our graph. Then I draw the second part of my line. It's a good color, green. Okay, and so this has a y-intercept of 0 because there's not anything there for our y-intercept. And we're going up 3, right 2. It's a dashed line, so I can't cheat and draw it myself. I mean, with the computer. Okay, and it's greater than that line. So which direction is greater than? Well, if I draw my arrow, it's this side, right here. So we're looking for, because our two lines make kind of an X that divides this up into, if you look, 4 different places. So one of the places should always end up not shaded at all. 2 of them should be shaded once, and then there should be one section that you had to color twice. That section that you had to color twice, that's our answer region. It's this part right here. And so what you want to do is one of two things. Either shade it more darkly, which don't cover up your line like I did, because it's really important that I can see that's a dashed line. So you can either shade it more darkly in that section, or you can erase the shading you did in the other two, whichever way you want to do it. But it's fine if you just shade darker where it overlaps and show that that's your answer, or at least it's fine with me. Number 26, we need to start off by solving for y. So I would subtract 2x from both sides on this first one and get negative y is less than or equal to negative 2x minus 2. But we're not done. We have negative y. That's not okay. We need to divide everything by a negative 1 to get rid of that negative y. But wait. I just divided by a negative, which means I need to flip the inequality. Y is greater than or equal to positive 2x plus 2. Then we can graph this. Now, this graph is kind of weird because it goes by 2's. Okay, but the way it works out is I can put my dot at 2, and this is saying go up 2 and right 1, and I can actually do that like this if I want to. I can actually go 2 tick marks and over 1 tick mark, and that's fine. And then down 2 and left 1. And then that's a solid line. So there's my solid line. Isn't that a beautiful, beautiful line? It is greater than that line, so we're going to shade above. So that's this side. Shade lightly. Then we need to solve the other one. So I would subtract x from both sides and get 2y is greater than or equal to negative x plus 2. Divide everything by 2. And I get negative 1/2 x, because there's a 1 in front of that x, and plus 1, because 2 divided by 2 is 1, and graph our line. So we start at 1. Now this one's a little trickier. We start at 1, which is halfway right here. Okay, and so I have to go down 1 and right 2. So down 1 gets me to 0, and then I go right 2 to here. So this time I didn't just use my tick marks. So I know that's kind of confusing. I'll try to make sure that doesn't happen on the test, but we'll see what happens. So I draw my line. It's a solid line. Should look like this. And then I draw below that. No, I'm sorry, I draw above that because it's greater than or equal to. So above this line is this direction, so I shade up here. So I have one place where I didn't shade at all, 2 places where I shaded once, and 1 place where I shaded both times. So that right there is where I need to shade more darkly for my answer region. Right there. Let's go. Let's go to the last problem, the last set of problems. Number 27, number 28. This is the linear programming stuff we did. It's not very much of it. It's not really the hardest part of what we did. It's the easy part, as long as you remember what you do. You have to plug in the corner points into the objective function they give us, and then look at what they're asking. 27 is asking for the maximum, 28 is asking for the minimum, and they're different objective functions, okay? So on 27, I need to plug in 2, 5, I need to plug in 4, 2, and I need to plug in 3, 3. So that I get 2 plus 8 times 5, which is 42. 4 plus 8 times 2, which is 20. 4, just kidding, not 4. 3 plus 8 times 3, which is 27. Okay, notice all of those are answer choices, okay, but we want the maximum, so we want the biggest number we got, which is 42. Now we want to do the minimum with this new objective function. So we have to sit here and plug in again. So 6 times 2 plus 7 times 5 is 35 plus 12, which is 47. Plug in 4, 2. 6 times 4 plus 7 times 2 is 38. And 3, 3. is 6 times 3 plus 7 times 3, which is 18 plus 21, which is 39. Okay, so our minimum would be C, which is 38. So there we go. That's it. Bye-bye.